Hey everybody, so we're going to be talking about polygons on the coordinate plane, and this uses coordinate geometry, which uses figures in the coordinate plane and to prove geometric concepts. So we can prove whether 3 points on a coordinate plane are a triangle or 4 points on a coordinate plane are a parallelogram, a kite, a trapezoid, square, rhombus, rectangle, whichever one. You could do that using any of these three formulas. And now the way that you use these formulas is going to be very strategic because each of them will do something different for you. So for slope, okay, you want to remember that your slope is y2 minus y1 all over x2 minus x1, which is the change in y over the change in x. This tells us that, helps us check, by the way, that our opposite sides are parallel. Okay, can also help us check if sides are perpendicular. So remember, that means it's got an opposite reciprocal. Pretty much this chapter combines close to everything that we did that first semester into one thing. Now, it also helps us check if diagonals are perpendicular. You're going to especially need that when you're checking for quadrilaterals because of kites. Okay, next up, you've got the distance formula. Right, now the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, this can help us check if sides are congruent and if diagonals are congruent. And then lastly, we've got our midpoint. Midpoint, remember, that's the average of your x values and the average of your y values. Okay, and this is great if you need to check whether diagonals are actually bisecting each other. And you can also check the coordinates of the midpoint of a side. All right, now we are going to go ahead and apply these and try to determine different things about the different shapes that we have. So first one that we're going to do is actually just determining whether triangle ABC is scalene, isosceles, or equilateral. So if you recall right here, a scalene means no sides are congruent, isosceles means two sides, and equilateral means all three sides are congruent. So what we're having to check for right here is going to be distance. You have to check the length of AB, BC, and CA. So I am going to set it up AB, BC, and CA. Notice it goes just like we've been taught and how we've learned to go ahead and label our lines. A, B, C, move it up one, pass it back. All right. Now, you'll notice that in this one, they didn't give you points. They gave you the graph. So your first step, okay, is always going to be label points on the graph. And this is just beneficial for you because you don't want to sit there and do that every single time. Right? So A right here is at 0, 1. B is at 2, 4. And C is at 7, 0. Starting you off easy with this first one, starting you off in the first quadrant. And then we move into all of the 4 quadrants. All right. So Remember that our formula for this is x2 minus x1 squared plus y2 minus y1 squared. All right. So I've got my x2, and I'm going to go with this side, my second point, being my x2 and my y2s. So I've got 2 minus 0 squared plus my y2, 4 minus my y1, which is 1, squared. All right, simplify inside those parentheses. So 2 minus 0 is 2. And then 4 minus 1 is 3. So we've got the square root of 4 plus 9, which is actually just the square root of 13. P.S. This is why you should know your perfect squares, because it makes your life faster. All right, so now we've got BC. We're going to do x2 minus x1 squared plus y2 minus y1 squared. Now remember, you can do it that your B is your x2, y2, and your C is your x1, y1. As long as you keep those numbers together, it doesn't matter which of the orders you use it in. All right, 7 minus 2 gets us 5. 0 minus 4 gets us negative 4. So then we've got the square root of 25 and 16 added together, which totals out to be the square root of 41. Okay, so far we know it's not an equilateral. It has to be either a scalene or an isosceles. So let's figure it out by finding the length of CA. So again, x2 minus x1 squared plus y2 minus y1 squared. All right, we get negative 7 here, squared plus 1 squared, 49 plus 1. Well, that would just be 50. And the square root of 13, the square root of 41, the square root of 50 are not going to all equal the same thing. Therefore, it's not even an isosceles. This is, in fact, a scalene triangle. All right. Now, remember, that means no congruent sides. All right. So with triangles, it's super easy that way. If you are asked to determine whether or not something is a right triangle, then you would need to check if two sides have opposite reciprocal slopes. If they're perpendicular, that's it. You only need to check for 2 of them. All right. Let's go ahead and determine stuff now based upon our quadrilaterals. So determine whether ABCD is a rhombus. All right, so first things first, we have to label our points. Okay, they've given us a graph, but they have not, they're making us actually go and graph these. So make your life easy, write them out. If you want to list them out, you can do that as well. That does get easy for some people, and I tend to prefer that way personally, but not everybody does. All right, so now that we've labeled our points, we also need to first check if it's going to be a parallelogram or not. All right, now the reason why I do this, and let me show you on a blank piece of on the back right here. All right, if you've got a quadrilateral, you have to check for a couple of things. Okay, first, you have to check if your opposite sides are parallel. Right? Now, if your opposite sides are parallel, okay, then it can be a parallelogram, it could be a rhombus, it could be a square, it could also be a rectangle. But that means it cannot be a trapezoid or a kite. The converse is also true. If your opposites, or sorry, if the two sides are not parallel, then it's not one of these, but that means that it can also be, the other end of it is that you're going to have trapezoids or kites. Okay, and we'll get to those in a second. So if your opposite sides are parallel, then it can be any of these four. But if all sides are going to be, let's see, because remember that your opposite sides are congruent in all of them. So we're definitely going to check if all of your sides are congruent, what happens. And that means it can only be a rhombus or a square. If we're being precise, that would be the most precise term that we could use. All right, so if all sides are congruent, well, it doesn't narrow it down between rhombus or square or parallelogram or rectangle. So you can also check then if the diagonals bisect each other. And if they are perpendicularly bisecting each other, so a 90-degree split, that means it's going to be a rhombus or a square, because all diagonals bisect each other in parallelograms. Right? If you are still, you're like, I don't know, I can't tell the difference because I'm stuck between the rhombus or the square, then you can check if all of your angles are congruent, meaning they're all 90 degrees. And you know that's only going to happen in my square or my rectangle. Now, what if both sets of opposite sides are not parallel? Then you're going to be working with either trapezoids or kites. Now, with trapezoids, only one set of parallel sides. Whereas with kites, you have no parallel sides. Okay, so then to differentiate, if you haven't figured that part out yet, or you're trying to figure out if it could be in one of the other shapes, then you also want to confirm that you have congruent diagonals on a trapezoid. This is the way you would set it up. First, you always check for slope. And that's what we're about to do on example 2. And then afterwards, to confirm, you're going to typically have to check for lengths, or in the case of kites, you're going to have to check if you have perpendicular diagonals. All right, so this is kind of what we finished off our entire quadrilaterals chapter with. It was that little chart that we had and the flow chart. This is why we make that, so it makes it easier for us when we have things like example 2 here, where we're having to figure out whether this quadrilateral is a rhombus or not. Well, first, in order for it to be a rhombus, you have to check if your opposite sides are parallel. And while you're doing that, you can also check if it's a square, if you're trying to determine between it's a rhombus or a square, because you'll get opposite reciprocals and see if something is perpendicular or not. Right, so let's go ahead and check for our slope first. And by the way, those of you that are like, well, I can just tell by looking at it, don't assume. All right, always check. Because they'll make it off by just a little bit, and that's how they'll get you. So let's check for a slope of AB, BC, I'm going to scooch over here, CD, and DA. All right, and this one is a little bit easier because it's already on the graph, and I can just do rise over run. The up 4 over 1, that's going to be 4. BC up 1 over 4, that's 1 over 4. CD, that is going to be up 4 over 1, that's 4. And DA, up 1 over 4. So your opposite sides are parallel. You can also tell that your opposite sides are not perpendicular. So you know that it's qualified for that first step. It is a parallelogram. Next, we have to check if all 4 sides are congruent. Right? So I'm going to go ahead and do it, and that we get AB, BC, and CD. Typically, when you're working with these types of shapes, if you already determined that it's a parallelogram, then what you can do is you might not have to check all 4. I'm going to show you and show all 4 done, but just in case. All right, so same formula, x2 minus x1, and then squared plus y2 minus y1 squared. So I get -1. Right, then you're going to simplify it. So -1 plus 2, well, that just gets you 1. Plus 4 minus 0 squared is 4 squared. You get square root of 1 plus 16, which is the square root of 17. Okay, let's do this next one, BC. So find the distance of BC. I would also recommend that you find the distance of CD. Right, so if you pause it and wanted to just double check, right here, I've got my work coming in. Okay, so notice that these 2 sides are congruent. Now, just because those 2 sides are congruent, you can't technically completely determine whether or not it's a rhombus yet. Okay, you do need to at least check if CD is also congruent, because if the opposite sides are parallel, then BC and AD would also be congruent, but you need to check CD at the least. Right, so then we get 1 plus 16, which is also the square root of 17. Which means we can tell that this last side, AD, is also going to be congruent. And if you're like, I don't know, I can't tell like that, I want to do all of them, please, go for it. It's not going to hurt you to do math. Well, some of you maybe, but... Okay, I get square root of -4 squared plus the square root of -1 squared. It's going to be the square root of 16 plus 1, which is also the square root of 17. Right? So all 4 are congruent. That means, yes, this is a rhombus. Now, I'd already told you, kind of to expect that a little bit. Now you get something like this. No graph, I just give you the points. And honestly, this one's usually a little bit easier for me. What I like to do, I always sketch. And I've given you guys graph paper if you want to use that graph paper. You don't have to. Some people like to use the graph paper. Some people just like to sketch it. The sketching just gives me a layout of everything. And the graphing part of it, it's more work for me to do. And I don't want to do more work. Work smarter, not harder. So we've got A, which is at 2, 4, and remember, I'm just sketching. So I want to see kind of what the layout of the land is. B is going to be at 4, -1, so a little further out, but below. C, a little out, and then down. And then D is at -3, further out, and then a little bit up. Okay? So you can kind of get the idea of what it might be, but do not ever assume what it's going to be. Okay, so first off, you have to check your slope. Okay, you can check for perpendiculars and parallels and all of this. So we are going to need to find the slope of AB, BC, CD, and DA. Remember, it's your change in Y over your change in X. If you've graphed it, it's going to be a little bit easier for you because you can do rise over run. Or if you're like me and you're like, no, I'll just do the algebra part of it. Okay, we can do this one right here. So you get -1, my y2 minus my y1 over my x2 minus my x1. -1 minus 4 is a -5. 4 minus 2 is 2. Right? I want you to go ahead and find the slope of the other ones. And you can go ahead and pause the video and come back and check the slopes. All right, so now that you're back, I've got my slopes down of each of my sides. So something that you will notice, and I noticed, is that, where did we go? Oh, oops, forgot a little symbol there. Okay, so what I noticed is that these two are parallel and these two are parallel. And now AB and BC and CD and DA were opposite reciprocals because it's flipped and you switch the signs. All right, so if I'm looking at this, I know that I'm first working with the parallelogram because my opposite sides are parallel. Then I also know that these are all going to be right angles, which means I'm either working with a rectangle or a square. So what I have to do now, in order to confirm whether it's a rectangle or a square, is you are going to have to check the distance of each of these sides, AB, BC, CD, and DA. All right, so I want you to pause the video, go ahead and find the distance. You can leave it as a radical, just like we did right here. We didn't have to go forth and simplify our radicals, because if the radicand is not the same, then your outcome, your final answer would also not be the same. All right, so thank you if you've paused the video. I do want to make sure that you show your work. So I am going to show the work for AB. The rest of them, I'm just going to have you check them. I did x2 minus x1 squared plus y2 minus y1 squared. 4 minus 2 is 2. And negative 1 minus 4, that gets you negative 5. Okay? Then we've got 4 plus 25, which is the square root of 29. And if you kept checking all of them, you got that each of these were the square root of 29. That means all of your sides are congruent. So yes, this shape right here is going to be a square.